This video will cover the Year 8 ratio and rates test preview. This is a huge video. It's a very long test. I'll put time tags below in the description so you can just skip to question numbers, and I'll put a description of what the questions are about as well. So if you don't have the test, you can use that to skip to the questions you want some help with. Let's start with question 1. We're looking at the ratio between two different things. So the first question has got semicolons in it. You'll notice this is the ratio symbol here. Okay, so whenever we see that, we know we're talking about ratios. And we've got the ratio of Santas to footballs. So I have got 1, 2, 3, 4, 5, 6 Santas. So I'll put it down as 6. And then footballs, soccer balls, I've got 1, 2. So I've got 2 soccer balls. Now, it's really important that you put the numbers down in the same order as the words, if that makes sense. So you can't accidentally switch the 6 and the 2. It's describing how many centers we've got per football. And this way as well, if you can simplify this fraction, you should. It's a bit like this ratio. This is a lot like a fraction. I'm just looking for common factors of 6 and 2, which is 2. So 2 will go into 6 3 times, and 2 will go into 2 once. So this is my final answer here. It did say in the question simplify where possible, so we have to make sure we adhere to that. Cars to rabbits, let's have a look. I can only see one car here. So we've got one car, and I've got 1, 2, 3 rabbits. Can't simplify that one, so that's simplified as far as it will go. And then rabbits to Santas, I can see 1, 2, 3 rabbits. And I can see 1, 2, 3, 4, 5, 6 Santas. This one we can simplify, can't we? 3 will go into 3 once, and 3 will go into 6 twice. So my final answer is a ratio of 1 to 2. Okay, so down below we're simplifying ratios just like we were doing at the top. I'm looking for factors of 24 that are also factors of 16. So what we might do is you don't need to write this, but what I'm going to do is I'm going to put a little note over here for you what I'm doing, okay? So what I'm doing is I'm actually dividing each of these by 8. So 8 will go into 24 3 times, and 8 will go into 16 twice, and that would make my final answer. In the next one, not many factors of these. I can probably only divide these ones by 2. So I'll do that, and I'll end up here with a ratio of 13 to 14. In the next one, I can see that I've probably got common factors of 14 here, because 14 will go into 56. But let's just say, for instance, that your times tables don't allow you to do that. That's okay. What you can do is you can do this in multiple steps as well. So if you're not sure about this, I can see 2 would go into both of these. So I'll just divide by 2, and then I'd have 7 to 20. Stuck myself here, haven't I? 28. Okay, and then I can see that 7 goes into both of those numbers, so I could divide them by 7 again, and I'd end up with 1 to 4. So I've ended up at the same answer anyway. So if I had done this straight out as 14 goes into both of those, then I would have skipped straight to 1 to 4. Okay, and then the final one, I reckon 160 will go into 4,000. So let's divide both sides by 160. Again, you could just keep skipping down. You could probably do it in tens. So if you've got a calculator, you can just pop it straight in. But let's just skip down. So this one would be 25 to 1. Okay, so let's do that. If I wasn't able to work that out, you can guess and check. You can test with your calculator if you are allowed a calculator. If not, what we could do here is we could just scratch a 0 off the end, so divide both sides by 10, And then we could try dividing by 16 instead, or by 8, because we know 8 will definitely go into 16 twice, don't we? And 8 goes into 45 times, so that means it goes into 450 times. And so then what we could do is go, great, well 2 goes into both of those as well, so we'd be back at the same answer of 25 to 1. So you can see there's lots of ways of getting down to the most simple form. Okay, 12 definitely goes into 48 4 times, so if we divide both these ones by 12, I'll make this one 12 times smaller and get 1. I'll make this 12 times smaller and get 4. 3 definitely goes into both of 39 and 6, so I'll divide both by 3, and that will leave me with 13 here. That should have been in blue, but never mind. And 2 here. What will go into 52 and 16? I reckon 4 will go into both of those. So let's try dividing both of those by 4. And I'll end up with 13 to 4. That's my final answer. And last one, 5 will definitely go into both of those. So let's test that first and see if we can go any lower. 5 will go into 125 25 times, and 5 will go into 15 3 times, and we can't go any further, so that would be my final answer as well. Great, let's move on. Question 3, we are going to write ratios in simple form, but we have to be careful. Look, the units aren't the same, so we have to convert these to the same units first. So if we convert 450 grams into kilos, what we're going to end up with is a decimal, and that doesn't sound like much fun. So let's keep them both to grams. So let's keep it at 450 grams, and we know there's 1,000 grams in a kilo, so we can make this 450 to 1,000. And then we know that if we make both of these 50 times smaller, so I'm dividing by 50, then what I'll end up with is a ratio of 9 grams to 20 grams. If you've got your calculator as well with these, there's a little trick you can do if you haven't worked this out yet. You can put them into your calculator as a fraction. You have to be careful and you put the small number over the big one. So in your calculator, if you dial it in, it won't work on your phone. It's got to be your scientific calculator. But if you put it in as 450 over 1,000, you hit equals, what you'll get is you'll get 9 over 20. And then you can write it in as a ratio. Now you have to be careful because they are different things. It's just using your calculator as a tool to help you. Let's keep going. We've got 4 weeks and we've got 6 days. We can't turn days into weeks very easily, so let's change the weeks into days. So there's 7 days in a week and we've got 4 of them, so we've got 28 days here. And we're comparing that to 6 days here. So 28 to 16, let's divide both of those by 2. And we'll end up with 14 days, or 2 weeks, to 3 days. Okay, let's keep going. We've got 70 cents and $3.50. Let's change all of this into cents. So we'll go 70 cents to 350 cents. Remember, there's 100 cents in a dollar. And we might divide both of those by 70. Again, you could knock out the tens if you wanted first, and then you could divide by 7. That would work as well. Whichever way works for you in your mind. We've got a ratio of 1 cent, excuse me, to 5 cents. Alrighty, and we've got 120 centimeters to 2.2 meters. Let's swap all of this into centimeters. 120 centimeters. Remember, the word cent means 100, okay? So there's also 100 centimeters in a meter. So we can convert those ones easily enough. And then we might divide both of those by 20 because I reckon that will work. So let's try that. Divide by 20. 20 will go into 126 times, and 20 will go into 220 11 times. 8 hours to 2 days. We better convert the days, I think. So we've got 8 hours still. 8 hours, and there's 24 hours in a day, so that's being compared to 48 hours. I reckon 8 will go into both of those. So we'll divide by 8 both sides, and we'll end up with a ratio of 1 hour to 6 hours. And the last one, we've got centimetres and millimetres, so we better convert our centimetres to millimetres, so that becomes 30 millimetres to 25 millimetres. 5 will go into both of those, so let's try that. Divide by 5 both sides, and I've now got a ratio of 6 millimetres to 5 millimetres. Fantastic. Let's go on to question 4. Question 4. In this one, I'm trying to find the value of m, okay? So we're sort of sneaking a bit of algebra into this one. So find the value of m. Remember, these ones are going to be ratios that have been simplified, and it's a little bit like equivalent fractions. The way that I look at this is I go, we know that the second number is going to match the second number, as in they're a pair, they go together. So what I do is I look at this number and I say, what did I do to that number to turn it into a 15? And in this case, what I did was I divided it by 2, okay? So what I'm going to do to the 6 is I'm going to divide that one by 2 as well, and that will mean that m is 3, okay? Let's try the next one. What did I do to a 5 to turn it into a 45? I times it by 9. So I'm going to times... Oh, I've gone back the wrong way. Let's go and try that a different way. What did I do to 45 to turn it into a 5? I divided it by 9. So I'm going to take the 18 now, and I'm going to divide it by 9 to give me m. So m will be 2. How did I turn a 7 into a 21? I multiplied it by 3. So I'm going to take the 6 and I'm going to multiply it by 3 to give me m. So m will be 18. How did I turn a 7 into 24? Well, that's a bit trickier. I might offer a couple of ways to do this one, I think. I'm going to imagine that I had to do this without a calculator first. So if I have a look at 24 and 7, if I put 24 over 7, then what I could do is multiply that by 5, and that would give me 120 over 7. Wow, there's a triangle as well. So what I've done here is I've made this a fraction, okay, and I've gone top times top, bottom times bottom, and I've got an answer there. Now, another way of thinking about this would be that 5 over 7 describes the relationship between m and 24. So we could also do 5 over 7 times 24. And this one would be one that would give you the same answer. Okay, so you'd end up with 120 over 7. And if you do this either way with a calculator, what you'll end up with is you'll end up with an answer of 17.14, rounded to 2 decimal places. So pretty tricky little question, that one, but it's really digging down at asking you what the relationship is between those two things. Might be a little bit easier for me to describe this in the next one. So let's try again and see what happens in question E here. How did I turn 12 into 18? Well, 18's 1.5 times bigger than 12. This one's a little bit clearer, isn't it? Because if I divide this by 2, I get 6, and if I divide this by 3, I get 6. So the relationship between 12 and 18 is 1.5. That means that m is going to be 10. I can see that, because if I did 10 times 1.5, I'd get 15. But we really do need a system where you guys can just put this into a calculator. So what I'm going to suggest is you choose whichever method you like over on the left in question D and stick with that, okay? So I like doing it so that I'm looking at this ratio, 12 over 18. So I'm going to put 12 over 18 into my calculator and multiply it by the 15, and that will give me the answer M, which is going to be 10. So M is 10. If you liked it the other way around and you wanted to use the ratio over here, then you would have chosen to say, I like it more if I do 15 over 18 and then multiply that by 12, and that would also give you the same answer of 10. So whichever one makes the most sense to you, you stick with it. It's just talking about the ratio between those ratios, really, isn't it? That makes it nice and simple and confusing at the same time. All right, let's keep going. So we've got another one of these as well. So we really need to just develop a system. So I'm going to go with, whoops, Daisy, I'm going to go with a highlighter. I'm going to go with, I know that I'm describing the relationship of 39 over 117, and I want to multiply that by 7 rather, so that I can work out what M's going to be, and that gives me the answer of 21. So M is 21. Let's have a look at the next one. How did I turn 20 into 35? Great question. So we're going to go 20 over 35, and I'm going to multiply that by 5, and that will give me what M is. So that's going to give me 8.75. So I know here that M is 8.75 as my final answer. Now I've crossed it out. Next one. How did I turn a 14 into a 50? I can see that I'm getting bigger in value, so I'm going to say 50 over 14, and I'm going to multiply that by 20 to give me the value of M, which is 71.43. So M is 71.43. So I hope I'm making this nice and clear. I might slow down a little bit and have a go at this one for you. Do you see how this number is smaller than this one? Okay. And so this number here has to be smaller than this one. So that's where I make the decision about which number I'm going to put on top, or the one that's with the M goes on top, if that makes sense. So I'm doing 1.3 over its corresponding ratio, 12, and then I'm multiplying it by, and then I'm multiplying it by 10.2 so that I can find M, which is the corresponding one to that one. And so that gives me 1.1, which sounds about right. So I say, great, M is 1.1, or 1.11 if you want it to 2 decimal places, and that's my answer. Skip down a line, there's lots of these, so I'll speed back up again. How did I turn a 7 into a 3.75? It's the smaller number, so it's going to go on the top. So 3.75 over 7 times 12 will give me the value of M, which is 6.43. So again, M equals 6.43. My final answer. And I've crossed it out again. That's unfortunate, isn't it? Okay, next one. How did I turn 19 into the 5? The 5 is the smaller of the numbers. It's going to go on the top because it's sitting next to the M. Times that by 15 to find out what M is. it will be 3.95. So answering properly, M is 3.95. Choose my highlighter this time so I don't cross out my answer. And last one, I've got a bigger number, smaller number again, so I'm going from 314 up to 115, so let's make it 115 over 314, because I'm trying to find out what the answer is on this side, and I'll times that by 3. That's going to give me the answer 1.10. So M is 1.10. And we've gotten through all of those. Question 5 would like us to convert these into unit ratios. Now, unit ratios are where we've got 1 to something. They're really useful. They help us particularly with scale and that sort of thing as well. So you might find that you get decimal answers in this one, and that's just fine. So what we need to do is choose the smallest of the two numbers and divide both numbers by that, basically. So use your calculator, divide both sides by 16. And what you'll find is you'll get 1, 2, 3. You'll have to put the numbers in one at a time in your calculator. You can't just go for it. Sometimes you'll see the answer. This one's nice and easy, isn't it? We'll divide both sides by the smaller number, which is 9. We know that 9 goes into 45 5 times, and we know that 9 goes into 9 once. In the next one, we're going to divide both by 10. This one's not too bad either. So we'll divide both sides by the smallest of the two numbers. 5.4 is the answer. So 54 divided by 10, and then we got 1. Over here, we'll divide by the smallest number again, so 7. We have to do them one at a time. 7 divided by 7 is 1. 23 divided by 7 gives us 3.29. This one, divide both sides by 2.5, and you'll end up with a ratio of 2.08 to 1. And last one, we'll divide both sides by 16 because it's the smaller of the two numbers, and we will end up with a ratio of 7.38 to 1. And those are all done. Next one, we need these ratios to be expressed in whole numbers. Okay, so we don't want any fractions in these ones. So what we'll have to do is bump both sides up in order to get the smaller of the number that's a fraction up to a whole number. And best way of probably doing this would be if we do it manually, what we'll do is we'll convert the fractions first. So this is equivalent to 9 to 9 on 4. And we'll do it this way because it's going to be a bit clearer what I'm up to when I do this. So now what I can do is make this one 4 times bigger on both sides. So 4 times 9 gives me 36. And remember that 4 times 9 quarters just gives me a nice 9 because we've made it 4 times bigger, so it's just a bit clearer. So let's do the same to the next one. Let's switch it over. So our fraction is going to be 30 over 7 to 12. And if you're wondering how I do those conversions so quickly, I say 4 times 7 is 28. 28 plus 2 gives me 30. And once I've got it to there, all I need to do is multiply both sides by 7. So now I'll end up with a ratio of 30 to 12 times 7 is 84. Okay, next one, we've got a decimal. I think the easiest way to get rid of this decimal is just going to be if we times it by 10, because that will move the decimal, or it'll move the numbers so the decimal switches. So let's multiply this one by 10, and if we make that 10 times bigger, we'll end up with 60 to 42. So that one's pretty good. Next one, we've got something that's to 2 decimal places. So again, the easiest thing is going to be to just multiply this one by 100. And what we'll end up with is 352 to 110. Now, we could simplify this ratio. It doesn't tell us we have to, so just keep an eye on that. It would be easy for us to bump it up like that and then shrink the fraction if that was what it was asking us to do, rather than to fish around trying to find out what the lowest number is that we could multiply it up by. Okay, let's do another fraction conversion. So we've got 4 times 12 makes 48. 48 plus 1 makes 49 over 12 to 3. And then we're going to make both of those 12 times bigger to get rid of that denominator down the bottom down there. Don't want it in fraction form. So we'll end up with 49 to 36 as our final answer. And then last one, this one's a whopper. Let's do 13, and then if we convert this, 5 times 21 is going to give me 210 divided by 2, which is 105 plus 1, so 106 21sts. And so we will multiply both sides by 21. 13 times 21 is testing me a little bit. 273 to 106 would be my final answer. Great, moving on to question 7. Write ratios and then solve the following problems. Okay, so we've got some worded questions here. We'll have to establish what the ratio is by the look of it, and then use it to solve things. So the ratio of men to women in Charlington University is 3 to 2.8. So we've got a ratio here of 3 to 2.8, and that is men to women. If there are 180 men, how many women are there? So this is just another equivalent ratio question, so we're just going to have to change that x. So what did I do to 3 to make it 180? I multiplied it by 60. So you can work that out easily with your calculator by saying 180 divided by 3, whatever number you get, in this case 60, you have to take over this side and you'll have to multiply 2.8 by 60. So x will be 168. So there's 168 women. We should write this as a worded answer. It's a worded question. Therefore, there were 168 women. Next question. The ratio of rectangle's sides is 2 to 7. If the longer side measures 105, the length of the shorter side. So remember, we're going a ratio of 2 to 7, okay? And so if we've got a ratio of 2 to 7, and it's telling me that the longer side is 105, what's the shorter side? A little bit different to the way that I did it the last time, just to mix it up a little bit. Remember, the way that we were doing them earlier is we were saying, well, we turned 105 from 7. If I multiply that by 2, that will give me what x is, okay? And so that means that x will be 30 centimetres. So therefore, the short side, poor touch screen, is 30 centimetres. Okay, next one. The ratio of chocolate to butter is 15 to 4 in John's recipe. If there are 0.2 kilos of butter, how much chocolate's required? Okay, so we've got chocolate to butter. We've got a ratio of 15 to 4. If there's, I'm going to just change this. If there's 200 grams, I don't like working with decimals if I don't have to. How much chocolate is required? Okay, how did I turn that 4 into 200? So remember, the other way of writing that is if I put 200 over 4, I don't have to do too much work that way, and I can just multiply that by 15, and that will give me how much chocolate there is, which is 750 grams. You don't have to answer this in any particular way, so you can just say, therefore, 750 grams, or 0.75 if you want to work it in kilos, of, well, chocolate is needed or required. Pardon my pen, it's writing all over the place. Okay, last question in this page. Last year, the ratio of road fatalities to days was 1 to... That's not a very nice question. If it was not a leap year, how many people died? Okay, so gross, we've got fatalities to days. It's a ratio of 1 to 6.76. It was not a leap year, so I know that there are 365 days in a year, and I want to know what that number there is. So remember, I'm trying to turn 6.75 into 365, so if I put 365 over 6.76 times that 1, then I'll get the answer 53.99. We might need to round this one, okay? So therefore, 54 people died. Just think about this one. It's not like measuring stuff. You can't have 53.99 of a person. We'll round it up to a whole number of people. Question 8. We need to convert these units into a ratio form, and so what we do is we get them back to a unit ratio. So remember, that means it's to 1. And so if you think about the things that you see in life, we're talking about kilometers per hour. So kilometers you're traveling per every hour that you travel. So the unit ratio in that case is 1 hour, okay? Or you might be talking about meters per second, or you might talk about liters per hour if you're talking about the flow of a pipe or something. So I find this difficult to explain, but what you need to do is this current ratio doesn't work. We've got 32 to 0.75, and that's just confusing. Now, stay with it, because the first question, because it's less than a second, seems confusing, but this process will work every time for you. Take the thing that you want to turn into a single unit, so this, because I want it to be revolutions per second, and divide the other number, or divide them both really, by the one that you want to make the unit. Okay, so in other words, I want that one to become 1. So if I divide this one over here by 0.75, I'll get 42.6. Okay, so I've got 42.6 revs or revolutions per second, okay? Or you can write it as per second if you want to. These are all worded questions. They should all be answered as worded responses, but it's going to take a really long time if I do that. So I'll just skip my answers ahead for you as I do them, okay? So let's go. We have got a certain number of meters, so 23.2 square meters every 4 litres. I don't want it every 4 litres, I want it every 1 litre. So what I'm going to do is I'm going to divide both sides by 4, and I'll end up with a new ratio of 5.8 to 1. And so what you're doing with your calculator is you're saying 23.2 divided by 4, and that's giving you the answer. So 5.8 metres squared per litre. Next one, I've got $1.50 for every 5.12 kilos. And that when we go to the shop, we get a price per kilo. So that means what we're going to do is we're going to divide both sides by 5.12, and I'll end up with a new ratio of 0.292, so basically 29 cents per kilo. So 29 cents a kilo. Next one, I've got $1.50 per 2.25 kilos, or 2 1/4. You can just put 2 1/4 straight into your calculator if you like. So same deal. I don't want that. I want it per kilo. So I'm going to divide both sides by 2.25, and my new value will be 67 cents. So 0. per kilo. And as a worded answer. And then what have I got? I've got 4.3 kilos every 34 days. That's not much good to me. I'd like to know what it is per day. So I'll divide both sides by 34. So just remembering, all I'm doing here is I'm choosing the thing that I want to be a unit. So this one here, and I'm dividing the other number by that. So I've got 0.126 this time. So this one's 0.13 kilos, or 130 grams per day. And last one, I've got 125 mils for every 4 litres. We'd like to know what it is for every litre. So we'll divide both sides by 4. And I'll end up with 31.25 for every 1. And that means we've got 31.25 mils for each and every litre. All right. Converting to kilometres per hour. Alrighty, so what have we got? 12 hours and we've got 30 kilometres covered. So let's rewrite this so that it makes a bit more sense. That means that I've covered 30 kilometres in 12 hours. It's very similar to what we're doing above there. I don't want to know what distance I'm covering in 12 hours. I want to know what I'm covering in 1. So I'll divide both sides by 12. And my new ratio will be 2.5 kilometres for every hour that I travel. So we'll go 2.5 kilometres per hour. Next one, I've got 11 kilometres in 40. So I've got 11.2 kilometres in 40 minutes. This one's a little bit more complicated. I might offer 2 ways of doing this one, I think. If I've got 40 minutes, this is a more advanced way, okay? So if you're feeling really confident with this, this would be an efficient way to do it. And then what I'll do is I'll do it a slightly different way that breaks it down a bit. So if I've gone 11.2 Ks in 40 minutes, that's no good. I want to know hours. So I also know that there's 60 minutes in an hour. So I've really only traveled 40 of the 60 minutes. Which means that if I flip it upside down and I multiply both sides by 60 over 40, that's going to turn this into 1, and it'll turn the other side into 16.8. So I've gone 16.8 kilometres an hour. That's nice. If that doesn't work for you, you might need to jiggle this around on paper a little bit. Remember here, if we did this, 40 times 60 is 2400, and 60 times 40 is 2400, and 2400 over 2400 gives us 1, which is why that works, okay? But let's say you still don't like that. I could understand that. The other way we can do it, if we do it in green, is if I've got 11.2 kilometres and I'm doing that every 40 minutes, what I could do is I could divide both sides by 40, and that would tell me how far I'm travelling every minute, which is 0.28. Now, we want to do it in hours, so what we could do then is we could multiply both sides by 60, and that brings this up to 60 minutes or an hour. Okay, so 60 minutes. And then this side would become 16.8. And so we've arrived back at the same answer of 16.8 kilometers per hour. You just need to decide which way makes most sense to you. This way is probably simpler, but takes a little bit longer. This way is a bit more efficient, but potentially a bit more confusing. C is a little easier. I'm covering 25. I've also swapped to green. I'm covering 25 kilometers in every 1/5 of an hour. So this one I can just times up by 5. If I make everything 5 times bigger, then I'll see that I am traveling at 125 kilometers per hour. 125 kilometers per hour. So that one's pretty good. Next one, back to being a bit more of a tricky one. This one, I've got 54 minutes for every 25k. So I want it as kilometers per hour. So I'm going to go 25 kilometers every 54 minutes. So I don't want it every 54 minutes. And I know that what I've really got here is 54 of 60 minutes. So the way that we did this one last time was what we did, we took the 25 and we multiplied it by 60 over 54. And that gave us our answer of 27.78 kilometers per hour. But we decided that if you found that that was quite challenging and you weren't too sure how we did that, the alternative was to take the 25 kilometres, because we know that we cover that in 54 minutes, and we could divide that down by 54. That way we knew that we were travelling 0.46 kilometres every minute, and then we could times this up by 60, and we'd end up back at 27.78 kilometers per hour. We times it by 60 here because there's 60 minutes in an hour. Whichever way is whichever way makes more sense for you. A couple of ways of approaching the next one. So let's have a look at that. We are covering, we've got to do quite a few conversions here. So we've got 190 metres. We don't want that because we've been talking about kilometres per hour, so we'll stick to that. So we know that we've gone 0.19 kilometres every 15 minutes. Now 15 minutes, 15 of 60 is really the same as a quarter of an hour, and most of us would know that 15 minutes is a quarter of an hour. So if we think about that, that makes life a fair bit easier, because what we can do is we can just times both sides by 4, and then we'll get our answer in kilometres per hour, which is going to be 0.76 kilometres per hour. Not very fast, but good answer. Okay, and last one. This one's a quarter of an hour as well, so this one's another good one to finish on. This one's 2.5 kilometres, isn't it? Because there's 1,000 metres in a kilometre, and that's per quarter hour. So we will do the same thing. We'll times both sides by 4, make them bigger, and then we will be travelling at 10 kilometres per hour. So nice easy one to finish on. Okay, question 10. Driving a car from work to home uses 16.2 every metre travelled. So we are using, we'll write that ratio down. We're using 16.2 millilitres of petrol per 1 metre. How many litres of petrol does it use if the distance covered is 30 kilometres? So if this one becomes 30 kilometres, what's this one? Now for starters, we've got 1 in metres and we've got 1 in kilometres. That won't really work, will it? There's 1,000 metres in a kilometre, so let's just make this one 30,000. And then we're comparing metres with metres, okay? And so What did we do to make 130,000? We times it by 30,000. So let's multiply 16.2 by 30,000. And that will give us X. So our unknown is 486,000 millilitres. Now that is a bit of a silly answer, isn't it? Because it's not the unit of best fit. So let's convert that to litres. There's 1,000 mils in a litre. So we'll divide this by 1,000. And we'll find that, therefore, it would use 486 litres to drive 30 kilometres. There's a couple of different ways of doing that, but so long as you arrive at that answer, you're fine. Question 11 is quite a detailed and complicated little question, but it's a great example of the overlap between fractions and ratios. So we've got some friends who have bought a house together and they've each contributed different amounts of money, okay? Now, what's happened is the house has gone up in value, so they've made a profit on it. And when they profit, they're going to divide the money up according to how much each person put in at the start. So what we need is we need a ratio. So I'll just pause this and write that out for you. So I'll try and keep this color coded for you so we don't lose track of each of the people. But we've got a ratio of Danny to Con to Sam to Jim, and they've contributed the different amounts of money together there. So it's only fair that when they split the $800,000 up when they sell the house, that each person gets the ratio of money that they put in, okay? So what we'll do is we better work out how much the house cost to begin with. So I'll pause again and write that out. So if we add it all up, the house originally cost them $430,000. Now I talked about fractions versus ratios. What we can do is we can use fractions to work out what each of these guys is entitled to. So Danny contributed 145,000 of the original 430,000. So that's his ratio, or that's his fraction of what he had contributed. So if we multiply that by the 800,000 that they sold the house for, that tells us that his portion should be 269,767. Now, Con, he contributed, so Con contributed 25,000 of the original 430,000. So quite a bit less than what Danny had originally put in. So if we multiply his portion by 800,000, he's only entitled to $46,512. We'll do the same for Sam. So Sam, pretty long question this one. Sam contributed 60,000 of the 430 that they paid. So his fraction or portion or ratio of the 800,000 will be 111,628. And finally, Jim, who put in the most, Jim put in 200,000. So we should expect him to get the most back of the 430,000, nearly half. If we multiply that by the 800 that they sold it for, he's entitled to $372,093. And that's been divvied up. And so our final answer is quite big, but it's this here, okay? So this is what each person is entitled to. All right, paint. To make a particular colour, a painter must combine the following quantities. It must be 2 1/5 of yellow to 1/4 of red to 4/5 of white. What's the ratio of yellow to red? and it says that you've got to convert it to a unit ratio in fraction and decimal form. So first of all, I'm only interested in yellow to red. So we'll forget about white altogether. So we've got 2 1/5 to 1/4 as our ratio. I don't like working with these mixed numbers. We're going to switch the fraction. So 2 times 5 is 10 plus 1 makes 11/5 to 1/4. And it said to me that we needed to make it a unit ratio. So one of these is going to have to become 1. It's easiest to convert that quarter. So we'll just make each side 4 times bigger. And that means that we'll end up with a ratio of 44/5 to 1. There's a couple of ways of writing this. It tells me that I have to answer it in fraction and decimal form. So that's a fraction form there. But the other thing is we could express it as a fraction as 8 4/5 to 1. That would be fine. And then if we want to write that as a decimal, we can do that as well. So if we've got 8 4/5, we've got 8.8 because 4/5 is 0.8, but you can do it with a calculator if you like. And if you don't know how to do that, on your calculator there'll be a F to D button. If you've got an abacus, you can just push that and it'll switch back and forward between a fraction and a decimal. And on a Casio, it'll be an S to D button. You can just push that and flick back and forward. Okay, if you had 3 litres of red, how much yellow does he need? So we did yellow to red. We probably should have written that in. So if he's got 3.5 litres of red, so he's got 3.5 litres of red, how much yellow does he need? Remember that we've created a ratio of 44/5 to 1. So what we need to do is basically we need to multiply 3.5. So I should write it neatly, shouldn't I? So X will be 3.5 times 44/5, and that will give us 30.8. So writing it as a written answer, he needs 30.8 litres of yellow. It's a very terrible 3. 30.8. It's actually getting worse. I'll stop writing. That's my final answer, which I've now crossed out. Okay. Final question of the paper. It says if the painter uses 3/4 of the originally specified amounts, let's assume that they're in litres, so 2 1/5, 1/4 and 4/5, how much of each is left over? Write it in a ratio form, either as a fraction or a decimal. Okay, well, if he's used 3/4, we'll write this down so it's nice and clear. If the painter, he or she, uses 3/4, there is 1/4 left. So all we need to do is find 1/4 of 2 1/5, 1/4 of 1/4, and 1/4 of 4/5. So let's work them out one at a time. We'll even do them in the right colours because it's the last question. So yellow, that's going to be 1/4 of 2 1/5. That's not a very nice number to work with. So 2 1/5 is equivalent to 11/5. Remember we did 2 times 5 makes 10, 10 plus 1 makes 11, 11 over 5. And so we will have 1 times 11 is 11, 4 times 5 is 20. Remember top times top, bottom times bottom of a litre. Or if you're using a calculator, you might get 0.55 litres. Both are fine. Red, same deal. We're having what is 1/4 of 1/4. Top times top, bottom times bottom, we've got an, oh, sorry, that's very bad math, isn't it? 4 times 4 is 16. So top times top, bottom times bottom, so a 16th of a litre, or in your calculator you might get 0.0625 litres. And last one was, oh, we're not going to be able to do white, so white's going to be purple. So white, what's a quarter of 4/5? Top times top, bottom times bottom. We better simplify that fraction. So this one's going to either be a 1/5 of a litre, or if you're using your calculator, 0.2 litres. So they'll be your final answers. This one's a 20.